Here we're going to look at topic 8, example 1, where we graph a linear equation. So straightforward, what is the graph of y equals 4/5 x plus 2? And what we want to know is that this equation is in slope-intercept form. All right, so we have slope-intercept form here. And what slope-intercept form is that we have something where y is equal to mx plus b. M is our slope, and b is our y-intercept. Sorry about that. So b is our y-intercept. So for this specific problem, our slope, our m value, is 4/5, and our y-intercept, our b value, is 2. So we could state that. So we would say that the y-intercept usually is what you want to start with. Not usually, sorry. You always want to start with the y-intercept. The y-intercept is the point 0, 2. So we're going to graph that. All right, so if I go to my y-axis, I'd have that point of 0, 2. Once I've graphed the y-axis, I then want to look at the slope. So remember, m is your slope. So the slope, m is equal to the slope, which you have something called, you have a vertical change. And a horizontal change. You'll also hear that referred to as the rise and the run, which in this case is equal to 4/5. So what that tells me, so all of this is my slope here. From the y-intercept, what I want to do is I want to rise 4 places. So I'll change colors here. We're going to take that point and we're going to go up 4 places here. Oh, that's only 3. Good thing I can count. 1, 2, 3, 4. And then we're going to run to the right. So we're going to run 5 places. And we can put our second point right there. So what that told me is I have a rise of 4 and a run of 5. And to draw that, to put the rest of the graph, I just, really play connect the dots. So I'm just going to connect these, hopefully do a better job of connecting them than I did, but you have something that would look like this. All right, we'll put little arrows because the graph is going to go forever to the left and to the right. And that would be the graph of y equals 4/5 x plus 2. So always start with your y-intercept. Once you have the y-intercept point plotted, you would then count from the y-intercept with your rise and your run. Your rise is going to be either up or down, and your run should generally always be to your right. There are going to be some exceptions, and one of that exceptions actually comes up in the triad example, but use a little bit of a challenge. I'm going to leave it up to you and see if you can figure that out. What would happen, if the graph isn't where you kind of want it to be, but you should be able to figure that out. I don't think you'll have too much difficulty. Think about kind of working backwards. All right, instead of going up and right, maybe I go down and left, maybe I go up and left, but think about what would happen with the slope of your graph.